The first one's sampling. And I won't get into sampling too much other than to say that the biggest issue that I see are sampling mismatches between the target and the prospects. So in other words, you might have a target, which might be, let's say, you know, everybody who's had a hip replacement in the last 2 years, and that came out of a particular, if it came out of your patient file, for example, there's a particular target market geo footprint for that sample. So it might be your primary target area, it might include the secondary area, or it might even include the tertiary area. Now that gets a little bit tricky because what if you have a lot of snowbirds in your footprint? And if somebody lives in Florida 3 or 4 months a year, but they live in the upper Midwest, you know, 8, 9, 10 months a year, and they know that they get a little bit of a discount if they get that hip replacement done in Boca, as opposed to, you know, Milwaukee or Minneapolis or Chicago or Detroit. Well, how can we get that particular patient prospect to have the hip replacement up north as opposed to down south? So sampling is very, very interesting because one of the things I have to ask my clients a lot is, what are you doing with your snowbirds? And if your patient population doesn't match your target population, you may have issues. So sampling and aligning your samples is incredibly important. The rule of thumb is you always want your target sample to match your prospect sample. So I just wanted to throw that one in there because it does come up as a problem quite a bit. Once you get the samples to match, then the analytics generally always run better. The next problem that comes up quite often is that of operational definitions. And that I kind of alluded to at the very beginning when I talked about value. Now, an operational definition is simply, from a measurement standpoint, what if I say hip replacement, what does that actually mean? So someone came in, they had an actual hip replacement surgery, period. Okay, does that mean they had the standard hip replacement? What about if they perhaps upgraded to better, you know, they went from plastic and steel to titanium, so on and so forth? Does all that count as a hip replacement? Or do we have two definitions of hip replacement? Another example of operational definitions on the women's health side that we deal with quite a bit is one, I would say, with the models that we build for breast cancer and mammography, I would say about 60% of our clients combine the two groups of subservice lines. So in other words, the mammography subservice lines and the breast cancer subservice lines are combined into one model. So you're combining breast cancer and mammography into one predictive model. So the operational definition is the combination of all the codes related to breast cancer and mammography. Whereas the other operational definition, there's actually two, because many of our clients, and these tend to be larger clients with huge patient databases, they'll tend to run separate models. So they'll have a standalone mammography model and they'll have a standalone breast cancer model. Well, now what you have are three different operational definitions. And that's simply what I'm saying here is we want to make sure that the operational definitions from everybody on the marketing team, including Evariant. Within Evariant, for example, is digital marketing using the same operational definitions as the client and the same definitions that I'm using, so on and so forth. So operational definitions, in other words, that which is being measured, how is it being operationally defined? Incredibly important. Once the operational definitions are aligned between the various silos and individuals and groups working on the project, things go better from an analytics standpoint. So operational definitions are huge. And the third one, and this is classic, and most of you probably remember this phrase, garbage in, garbage out. All that means is that we want to make sure, and this is, I can't emphasize enough how important on the front end that I mentioned earlier that the data cleaning, the exploration, and the description is critical. And the one of the bigger issues that is actually less addressed than others is that of outliers. A lot of clients and a lot of what we do on the front end, we do incredibly good work with missing data. What's a little bit harder to deal with, that I have to deal with from a modeling standpoint, but it's difficult for clients to deal with it, especially when they don't have that much, when they don't have total 100% control over their data system or their platform. And that's that of outliers. And outliers, you know, the classic example of an outlier, let's say that you have 100,000 records and one of your variables is some kind of a score, and the score ranges from 1 to 5. It might be sort of a Likert scaled score, but in that particular file, 5% of the records have a 10 in there. Well, first of all, how did the 10 get there? And from a classic statistics standpoint, if 5% of my distribution includes 10s, when the range of scores should be 1 to 5, I know almost immediately that even 5% of an abnormally high outlier score of 10, that's going to throw off my entire distribution. If my distribution is thrown off, then everything that's related to that particular variable will be thrown off. So the rule of thumb is that you want to deal with outliers before you deal with missing data, especially since much of the data much of the work statistically that's done on missing data requires imputations and different types of algorithms that will sort of predict what should go in that particular missing cell. Well, some of those algorithms are based on mean scores, which is one of the 3 averages. And if it's based on a mean score and you have outliers in there, your imputations for missing data are not going to work properly. So you have to deal with the outliers first, then you deal with the missing data. But one of the biggest issues that we deal with on a regular basis is the dirty data issues on the front end. So whether it be on our side, my side for modeling, on the client side, always have a good handle on the front end. And for those of you who have been through my modeling pre-briefing calls, one of the statistics that I throw out there is that in a given predictive modeling exercise, probably 60, maybe even up to 70% of all the work that's done with the data is done on the cleaning and prepping side of the data, not so much the predictive analytics. Because once the data set and you spend all that time cleaning and massaging and making sure all of those data issues are taken care of, then the modeling piece and the multivariate analytics goes very, very, very smoothly. What really throws a wrench into the whole operation is if you start working on the multivariate analytics and realize that there's problems in the data, you have to stop what you're doing and literally start over, because you have to go back and reconfigure the data set, because you need to clean what's missing, you need to fix the outliers, and so on and so forth. So those 3 issues are critical.